بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is the first lecture of Math 111 Calculus 1. We are using the book Calculus Early Transcendental Functions, the 9th edition by Stewart and others. We will start by chapter 1, section 1.1. Chapter 1 is about functions and models. Section 1.1, 4 ways to represent a function. Let us first remind ourselves with the definition of functions. Functions arise whenever one quantity depends on the other, on another one. So we have two quantities, one of them depends on the other. For example, here we have A and R. A is the area of the circle and R is the radius of the circle. So here R and A are connected by this equation. A equals pi r square. This is the formula for the area of the circle. And now A depends on R. If you change R, A will be changed. If you give R, if R is 1, for example, A would be pi. If R is 2, A would be 4 pi, 2 square, 4 pi. So we say that A is a function of R. So here we have two quantities, A and R. A depends on R, so A is a function of R. A function f is a rule that assigns to each element x in a set D exactly one element called f of x in a set E. So we have two sets D and E, and the function f takes, so here for example, this is the set D, this is the set E, and f is the function that takes x, which is in D, to f of x, which is in E. So that's the definition of the function. Usually in this book, we will talk about sets of real numbers. So we will not consider the complex numbers or the non-real numbers. The set D is usually called the domain of the function. So D is the set of all possible values of x. X is taken from D, okay? So when we say that D is the domain, so the domain, all possible values of x. Now f of x would be the value of f at x, okay? We read it f of x, and the range of f would be the set of all possible values of f of x. Set of all possible values of f of x, where x is in the domain. Now, usually the two variables in the function, one of them is called the independent variable, and that's x, that's the number in the domain, okay? And the dependent variable would be the number that comes out in the range, okay? The number in the range. So here in this example, a equals pi r square. R is the independent variable and A is the dependent variable. A depends on R. If you change R, A will be changed. So R is the independent and A is the dependent variable. You can look to the function as a machine. This is a machine. F is the function. It is a machine. X is the input. You put X inside the machine and the output would be f of x, okay? So the input is the domain, the possible values of x, and the output would be the range, f of x, okay? The value of f at x. The programmed functions in a calculator are good examples of function as a machine. If you input a number and press the squaring key, for example, squaring key in the calculator is a function. You put 2, you press the square key, you get 4. So the input is 2 and the output is 4, and the squaring key is a function in the calculator. We can also write the function or the graph of the function as set of all ordered pairs x and f of x. Okay, such that x is in the domain and y is f of x. Y is f of x. For example, and pay attention to this, please. Now, this is the graph of the function. Okay, these are the x values. So 1 is a value in the domain. Where is the output? 1 is the input. Where is the output? It is f of 1. Where is f of 1? It is this number. If you go here, it is this number. This is f of 1. This is 2 x value, and this is f of 2. F of 2 is a y value. This is x, and this is f of x. Okay, so this point is x and f of x. And if you graph all of these points, you have the graph of the function. So you can, from the graph, if you have the graph of the function, you can find f of any number, f of x, using this method. And also you can determine the domain and the range. The domain, all possible values of x. So you bring this point down, the last and the first points in the graph, and this would be the domain from here to here. And to find the range, all possible values of y that are in the domain. So this is the lowest value of y, this is the highest value of y, and the range would be between these 2 points. So this is the domain, all values of x, and the range, all values of y. And let us have this example. This is a function, f, and the question, find the values of f of 1 and f of 5. Okay, well, this is 1. And to find f of 1, I go up to here. This is f of 1. If you go here, 1, 2, 3. So f of 1 is 3. So what is f of 1? It is 3. Similarly, we can find f of 5. Where is 5? This is 1, 2, 3, 4, 5. So this is 5. Okay. What is f of 5? This is 5. This is x5. 2, 3, 4, 5. I go up, there is no graph, so I go down. Here, this is f of 5. It is not -1, it is less than -1. So we can say that f of 5 is approximately -0.8 or -0.9. Okay, so that's f of 5. So we can find f of any value in the domain of the function. What are the domain and the range? Okay, let us try to determine the domain and the range. To determine the domain and the range, this is the first point. So I go down here, and this is the last one. So up to here. So the domain, all possible values of x from here to here. This is 5, 6, 7. So the domain is from 0 to 7. The domain of the function f is from 0 to 7. What about the range? What is the range? The range, all possible values of y. Okay? So I work with the y-axis. Where is the smallest y here? Here. This is the smallest value of y, which is -2, okay? And if you go up, this is the largest possible values of y, which is 4. So the range would be from -2 to 4. From -2 to 4, that's the range of this function. Okay. Now, the most common method of defining a function is using algebraic equation like this. Y equals to x minus 1. Okay, so here x is the independent variable, y is the dependent variable, and we say that y is a function of x. Okay, we can replace y by f of x because y is always f of x. So we can write it f of x equals to x minus 1. Let us see this example. Sketch the graph and find the domain and the range of this function. If you remember, this is a linear function because x has power 1. And this is really written in the form mx plus b. So m, it's the graph of this function is a line, a straight line, and the slope is 2, the coefficient of x, and b, which is the y-intercept. When you put x0, you get the y-intercept, which is -1. So to graph this line, I can start from -1. This is the y-intercept, and use the slope to get another point on the line. If you remember, the slope is delta y over delta x. That's the definition of the slope. It is the change of y over the change in y over the change in x. It is 2, so 2 can be written 2 over 1 or 4 over 2 as you wish. So 2 over 1. If you change x by 1, so if I go 1 unit to the right, okay, I should go 2 units up. So I change y by 2. So I go 1 here and 1 here. So I reach this point. So these 2 points belongs to the line. So just I can connect them, and this is the graph. This would be the graph of the line y equals 2x minus 1. And the slope is 2 over 1. So this is the graph of the linear function. Now, this is another function. This is the square function, the quadratic function, x squared. How to graph x squared? Well, we know that the graph of x squared is a parabola. If you do a table of coordinates, if you choose x -1, y would be -1 square, which is 1. If you choose x0, y would be 0, 1, 1. So if x is -1, y is 1. If x is 0, y is 0. And if x is 1, y is 1. And it's a curve. So you connect these 3 points like this. And this is the graph of y equals x squared. If you don't know the graph, you can choose x to be 2, for example, and you will find that y is 4, -2y is 4, and so on. So it is a parabola. That's the graph of x squared. So this is a linear function, and this is a parabola. Another example, if this is a function f of x, evaluate f of a plus h minus f of a over h. Now this is f of x. What would be f of a? Well, if this is f of x, I need f of a, so I just replace x by a. So I write it 2a squared minus 5a plus 1. All right. What about f of a plus h? Well, it is the same. I have f of x, and I need to find f of a plus h. So this would be replaced by x. So I write it 2 times, I replace x by a plus h and I put the square, then minus 5. Again, I have x, so I replace it again by a plus h, and then I have plus 1. Now I expand this, so it would be 2 times. If you expand this, you remember that you square the first term plus 2 times the first times the second plus the second term squared. So this is how we square a binomial. And then you multiply by negative 5. So it's negative 5a. And you also multiply negative 5 by h, and you have plus 1. So now let us find f of a plus h minus f of a over h. Let us write f of a plus h from here. It is 2 times a square plus 2 times 2, 4ah, plus 2h square, multiply 2 by all the three terms, minus 5a minus 5h plus 1. And now minus f of a, this is f of a. If you multiply f of a by a negative sign, then the negative sign would be multiplied by all the three terms. So I will have negative 2a square minus times minus would be plus 5a, and multiply plus 1 by negative, so it would be negative 1. All of this over h. And as usual, if you remember, we notice that all the terms without h, so this is 2a squared, it must be cancelled. So you must find negative 2a squared here. This is with h, okay, with h, okay. This is negative 5a without h. It must be cancelled. So there is a 5a here, so they will be cancelled. 1 has no h, so also you must cancel this number. Otherwise, you made a mistake here, okay. So now what would you have? We will have 4ah plus 2h squared minus 5h, that's it, okay, over h. Now what should we do? We take h as a common factor from these three terms. So we will have 4a, because we took h, plus 2h. The way you take a common factor, you divide 2h squared divided by h, then h cancels with h and you have 2h, minus 5h divided by h, you get the 5 over h, and now you can cancel h with h, and the final answer would be 4a plus 2h minus 5. So that's the answer of this example. This expression, f of a plus h minus f of a over h, is called the difference quotient. The difference quotient, and it is known in calculus. It occurs frequently in calculus, and we will talk about it again and again. It represents the average rate of change, the average rate of change of f of x between a plus h and a, between a and a plus h. So it's the average rate of change. Let us solve example 6. Find the domain of each function. The domain, set of all possible values of x. Whenever you have a square root, I cannot accept that the square root, the thing inside the square root cannot be negative. So x plus 2 cannot be negative, because if you put in the calculator square root of negative 1, you will get a math error, okay? It's not a real number. So x plus 2, which is inside the root, must be greater than or equal to 0. So if you take 2 to the other side, this means that x is greater than or equal to negative 2. The domain set of all possible values of x, and x is greater than negative 2. So it is here greater than negative 2. This is infinity. So the domain would be from negative 2 to infinity. Another question here, I have a fraction. Well, we cannot accept that the fraction, the denominator cannot be 0. 1 over 0 is not defined, is a math error. So let us factor the denominator. If you take x as a common factor, you will have x squared over x, which is x, x over x, which is 1. So now I can see that x cannot be 0, because if x is 0, then 0 times anything would be 0. And x minus 1 cannot be 0. This means that x cannot be 1. So the domain of G would be all real numbers except 0 and 1. Or we can write it as, so we need, if this is 0, so 0 shouldn't be there and 1 shouldn't be there. But all other elements, all other numbers from negative infinity to infinity are there. So I can write it in interval notation from negative infinity to 0, union from 0 to 1, this area and this region, this interval, union from 1 to infinity. So this means all the real numbers except 0 and 1. Now the vertical line test. How to find out from the graph whether the graph represents a function or not? Well, if each vertical line or if no vertical line intersects the curve more than once. More than once. So here, if you draw vertical lines, each vertical line intersects the graph in one point only. So this is a graph of a function. This is a function. The blue curve is a function. While the blue curve here is not a function because this vertical line intersects the graph in 2 points more than once. So this does not represent a function. So the circle, for example, the circle is not a graph of a function because the vertical line test does not work. For example, this parabola x equals y squared minus 2. The graph of this parabola is this one, x equals y squared. The graph is like this, and minus 2, you take it 2 units to the left. So this is the graph of x equals y squared minus 2. It's not a function. It's not a graph of a function because this vertical line intersects the graph in 2 points. So it's not a graph of a function, all right? Because y has power 2, okay? But if you solve this equation for y, okay, if you take 2 to the other side, then y squared would be x plus 2. And then if you take the square root, then y would be plus or minus square root of x plus 2. So there are two functions here. Y equals square root of x plus 2, where y is positive, so it's the upper half of the parabola. And y equals negative square root of x plus 2, that's the lower half of the parabola. Okay, so this parabola contains inside it two functions like this. The upper half of this parabola is a function, and the lower half is also a function. Now, what about what we call piecewise functions? Okay, piecewise functions are functions that have more than one definition. So, for example, this f of x has two definitions. It is defined as 1 minus x if x is less than or equal to -1, and it's defined as x squared when x is greater than -1. So there are two definitions according to these conditions. Okay, how to find f of -2? Well, to find f of -2, I have to look for x equals -2. -2 is the value of x. Now, is -2 greater than -1 or less than -1? So this is -1, okay, and this is 0. Where is -2? -2 is here. So -2 is less than -1 because it's to the left, okay? So it's -2 is less than -1. So now I have to use the first definition. So to find f of -2, I replace this x here by -2, and the answer would be 1 plus 2, which is 3. How to find f of -1? Well, -1, is it less than or equal to -1 or greater than -1? The equality sign is here. So again, I will use the first definition. So it's 1 minus -1, 1 plus 1, which is 2. But f of 0, now 0 is here. It's greater than -1. So I cannot use the first definition. I should use the second definition. So f of 0 is 0 square, which is 0. And sketch the graph. Now to sketch the graph of this function, we have to pay attention to the point or to the value of x -1. Now, when x is -1, to the right of -1, I have a definition. So to the right of -1, f of x equals x squared. To the left of -1, f of x equals 1 minus x. So I need to graph the two graphs, this one and this one, but this one here in this part and this one in the left part. The graph of this function is just a straight line. So to graph a straight line, I need 2 points. Y equals 1 minus x, 2 points. Okay, I need to choose x -1 because -1 is the border. So 1 minus -1, it is 2. So at -1, it is 2, okay? And I choose another number here, another value of x to the left of -1, because this function is to the left of -1. So for example, I choose -2. So f of -2 would be 1 plus 2, which is 3. So at -2, it is 3. And that the line connects these 2 points. Is -1 included? Well, 1 minus x, the equality sign is here with this part. The equality sign is with this part. So this would be a closed point, and the graph of the line would be like this. Okay, so that's the graph of 1 minus x, the part of 1 minus x to the left of -1. I shouldn't continue with a line to the right of -1. It's not a line. To the right of -1, it is x squared. It's a parabola. Okay, I know the graph of x squared. It's a parabola. So, but I need to choose some points, and the points would be, the first point to choose is also the border. I need to know at -1 it's equal to what? So it is 1. So at -1 it is 1. But -1 is not with this function, it is with this function. So it is 1. I put here an open circle. Okay, so if you graph a vertical line, it passes by 1 point, so it remains as a function. And at 0, it is 0. And at 1, because I have to choose points to the right of -1, it is 1. So I continue, I graph the parabola like this. That's the parabola. Okay, so this is the graph of the function f of x. 1 minus x to the left of -1, and x squared to the right of -1, and the equality sign is with the line with 1 minus x, not with the parabola. The next example of a piecewise function is the absolute value. In fact, the absolute value is a piecewise function. What is the definition of this symbol? It is the distance from a to 0 on the real number line. Okay, so absolute value, for example, this is the real number line. This is 0. This is 1. This is 2. This is -1. This is -2. Now, what is the absolute value of 2? The distance from 2 to 0, 1, 2, 2 units. What is the absolute value of -2? The distance from -2 to 0, which is 1 to 2 units. Okay, so if a is positive, if the number is positive, absolute value of a would be equal to a. But if a is negative, if the number inside the absolute value is negative, then absolute value of a is not a, it is negative a. So in fact, the absolute value of -2 is -2, which is 2. So absolute value of a is -a in this case. And remember, a is negative, So negative a is positive, and the absolute value is always positive. So absolute value of a is always greater than or equal to 0. Sketch the graph of the absolute value function. Well, the definition of the absolute value, it is either x if x is positive, and it is negative x if x is negative. So that's the definition of the absolute value function. Okay, how to graph? It's a piecewise function. The number here is 0. Okay, to the right of 0, the graph is f of x equals x or y equals x. To the left of 0, I have to graph y equals negative x. This is a straight line and this is a straight line. If you choose points, okay, here, the first value to choose of x should be the 0 because it is the border. So 0, if x is 0, y is 0. And I choose another number to the right because I need to graph it to the right of 0. So if you choose x1, y would be 1. So it passes by 0 and 1. The equality sign is with this one. So this would be the graph of the line y equals to x to the right of the 0. To the left of the 0, okay, y equals negative x, I should always start by the 0, the border. So it's negative 0 is 0. And I choose a number to the left of 0, which is negative 1. Negative 1 would be 1. So at negative 1, it would be also 1. So it will pass by 0, 0, and negative 1, 1. And this would be the graph of the absolute value function. Even and odd functions. This is the definition of the even function. If for each x in the domain, f of negative x equals f of x, then f is called an even function. Okay. For example, x squared is an even function because if you find f of negative x, it is negative x all square or x squared, which is the same, which is f of x. Okay. So f of negative x is equal to f of x. So this function is an even function. Geometrically, this means that the function or the graph of the function is symmetric with respect to the y-axis. Okay, so this is the graph of x squared minus something. It is symmetric with respect to the line y, the y-axis. Okay, notice that if this is x, this would be negative x, and you can find that f of x is exactly equal to f of negative x. So f of x is the y here, f of negative x is this y, and they are equal. So for the even function, the graph is symmetric about the y-axis. For the odd functions, okay, we have f of negative x equals negative f of x. And for each x in the domain. For example, f of x equals x cubed. If you find f of negative x for this function, which means you replace x by negative x, so you have negative x all cube. Now for the cube, the minus comes out, so I'll have minus x cubed, and this is minus, and x cubed is f of x. So f of negative x equals negative f of x, so this is an odd function. So x cubed is an odd function. The graph would be symmetric about the origin. The graph of an odd function is symmetric about the origin. If this is x and this is negative x, if you find f of x and f of negative x, they are different by a minus sign. So if f of x here is 2, for example, this would be negative 2. So f of negative x is equal to negative f of x. So the graph is symmetric about the origin, which means this point, if you take a line to the 0 and continue with the same distance, you will get the other point, which is symmetric to the first one. Now, example, determine whether each of the following functions is even, odd, or neither even nor odd. How to find out? I find f of negative x. Okay, what is f of negative x? I replace x by negative x, so I replace x by negative x to the power 5. and then this x also is replaced by negative x. Now this is an odd power, so the minus negative 1 to the power 5 is negative 1, and I have x to the power 5, and then plus times minus is minus. Okay, now if you take minus as a common factor from these two terms, I will have x to the power 5, and negative x over minus is plus. So I will have, if you take minus as a common factor, you will have x5 plus x, and this is f of x. So f of negative x is equal to negative f of x. So f is odd function because f of negative x equals negative f of x. What about this function? To find out whether it's even, odd, or neither, I find g of negative x, which means I replace each x by negative x. Now this is 1 minus. You cannot multiply negative by negative because there is a power here. So first evaluate the power. Negative 1 to the power 4 is positive. So I have x to the power 4. Well, 1 minus x to the power 4 is exactly g of x. So g negative x equals g of x, which means that g is even, an even function. Let us find here h of negative x. h of negative x is 2 times negative x. You replace x by negative x minus negative x all squared. Okay, so it would be this negative comes out negative 2x. Okay, because negative 1 times 2 is negative 2. And the minus sign will be positive because it's negative 1 to the power 2. So this would be positive. So I have x squared. And this minus is remains there. It's still there. So negative 2x minus x squared. Well, if you take minus as a common factor, it would be 2x plus x squared. Okay, so this is not equal to negative f of x, and it is not equal to f of x. So h, okay, h, the function here is called h. So h of x is not equal to h of negative x. They are different. This is different than this because here I have 2x, here I have negative 2x. And if you multiply h by negative, what is negative h of x? It is negative 2x, and negative times negative would be positive x squared. So it is not like this because here I have negative 2x, negative x squared, not positive. So h of negative x is neither equal to negative h of x nor equals to h of x. So h is neither even nor odd. The last point I believe in this section is increasing and decreasing functions. If you look to this graph, this is a graph of a function f of x. The graph rises from a to b, then falls from b to c, then rises again from c to d. So we say that the function f is increasing, rises, on the interval a to b. So you write the interval on the x-axis. So the function is rising from a small a to small b. So we say that it's increasing on AB, decreasing on, it's decreasing where? From B to C on the x-axis. So it's decreasing on BC and increasing again from small c to small d. Okay, so it's increasing again on CD. If you take any two numbers, x1 and x2, such that x1 is less than x2, so here in the first interval, in this interval, take these two numbers, x1 and x2, where x1 is less than x2 to the left of x2. Find f of x1, find f of x2, you will find that f of x2 is greater than f of x1, okay? So whenever x1 is less than x2, f of x1 is less than f of x2. This means this is the definition of the increasing function. So we say that f is increasing whenever f of x1 less than f of x2, whenever x1 is less than x2 in that interval. if f of x1 is greater than f of x2, when x1 is less than x2, then the function is decreasing. For example, here, if you take x1 and x2, x1 less than x2, you will find that f of x1 is greater than f of x2, not less than, because that's because the function is decreasing. So here, for the quadratic function, the parabola, y equals x squared, we notice that the function is decreasing on the interval negative infinity to 0, decreasing, and increasing from 0 to infinity. We stop here, and that's the end of this section 1.1. Thank you very much, and I stop here.